Hey, it's T. I'm one of the geniuses at Ask Zylor. So let's just get started with the live session. So the first question is asking us to find the extrema of a sinusoidal function. We have to determine any extrema between the periods of negative pi and pi. Okay. So the first thing we should be doing is finding any local extremas. So let's go ahead and find the derivative of my function. So I have a y is equal to sine squared x minus sine x. So I'm going to go and find the derivative of that. So I need to find the derivative of sine squared x in terms of x, and then sine x over dx. So if you have any questions, send them in. We'll be happy to answer them either on the live, or we'll send you a message and answer them separately as well. So let's go ahead and keep finding the derivative. So sine squared x is going to be, the derivative is going to be 2 sine x cos x. And then the derivative of sine is just going to be minus cos x. Right. So then I'm looking at when is my first derivative equal to 0, so I can try and factor out a common term. So I know cos x is a common term in both these terms, so I have 2 sine x minus 1 and cos x. So then I can look at when is cos x equal to 0 and when is 2 sine x minus 1 is equal to 0. So cos x is equal to 0 when x is either equal to pi over 2 or when x is equal to negative pi over 2. Right, and then 2 sine x minus 1, that's sine x is equal to 1 over 2. So x is equal to pi over 6 or 5 pi over 6. So what we're going to do next is the second derivative test. So what we're going to do is find the second derivative and plug these points into my second derivative. So we're going to plug it into the second derivative to tell me is it either a min or a max, right? Because my second derivative is talking about concavity. So in concavity, if I have a positive number, that means I have concave up. If it's negative, I have concave down. So if it's concave up, that means I have a minimum. If it's concave down, I have a maximum. So in order to do that, I need to go and find my second derivative. So my second derivative is going to be the derivative of cos x sine 2 sine x minus 1. So I need to get this in terms of x. So I immediately see that it's a product rule. So I'm going to get the derivative of the first term. So the derivative of just cos x multiplied by 2 sine x minus 1 in terms of dx. And I'm just going to add with the first function and the derivative of the second function. So 2 sine x minus 1. So we're doing some questions that students have been sending in, some questions that we commonly see throughout the week. So if you have any questions, send them in. We'll be happy to help you out. So let's go ahead and evaluate this. So my second derivative, the derivative of cos x, is going to be negative sine x. And then I'm just multiplying by 2 sine x minus 1 plus cos x, and the derivative of 2 sine x is just going to be cos x. And I can't forget the 2 for that. So this simplifies to negative 2 sine squared x minus gives me plus sine x, and then I have, this is a bracket, so I have plus 2 cos squared x. So then what I'm going to do is basically substitute the 4 points. So the 4 points I had was pi over 2, negative, let me write this down. So I had pi over 2, I had negative pi over 2, I had pi over 6, and 5 pi over 6. Right, so I'm just going to plug those values in. So pi over 2 is going to give me negative 2 sine squared pi over 2 plus sine pi over 2 plus 2 cos squared pi over 2. And that's all going to evaluate to negative 2. So this negative tells me that I have a concave down, so that means I have a local max. Right. So what we're trying to do is find out if there's any, the question's asking me determine any extremas for my function sine squared x minus sine x. So it requires me to find my first derivative to find out any local min or maxes. Then I'm using those values that I found. I found 4 of them. And then I'm plugging them into my second derivative to test, is it concave up or concave down, which will tell me if I'll have a min or max. So I went through, I found my second derivative, which came up to negative 2 sine squared x plus sine x plus 2 cos squared x. Then it's a matter of substituting these values into my second derivative to get a positive or negative number. So I did my first point, pi over 2, to give me negative 2. Then I'm going to do negative pi over 2, which should give me a negative 3, which tells me it's again still a max. So I'm going to go ahead and plug in pi over 6. I'm just skipping the steps because it's easy just to plug in these values into the x. So pi over 6 is going to end up being 3 over 4. So that's a positive number, meaning I have a concave down, meaning I have a local min. Right? Concave down means I have a curve that's opening upwards. And then the last one is 5 pi over 6, which is going to be again 3 over 4, which is again a positive, meaning I have a positive concavity, which is again a local max. A local min, sorry. So the next question is a grade 9 math question. It's dealing with linear functions. So it's telling me a parking lot charges $2.50 per hour. Create a table of values for the cost over 0 to 5 hours. So this, my table of values, is going to be, I'll say x is, let's say t is time in hours, and c is cost in dollars. So if time is 0, I have no cost. If time is 1, for every hour I'm charged $2.50, so for my first hour I'm charged $2.50, for my second hour I'm charged $5, and so on. So this is 7.5, and it just keeps going. 4 is 10, 5 is 12.5. I can notice that the difference between each one of these is 2.5. Right? That tells me it's a linear function. So I calculated the first differences because I just need to find the difference between each of my cost values. So I found that each one of them is 2.5. Is this a linear function? It is a linear function because my first differences are the same. If my first differences change, that means I don't have a linear function. So is this a linear function? Yes, because of first differences. And part D is asking me write an equation for the cost of parking for 24 hours. So I'm going to say cost is equal to something in terms of time. So how much am I charging per hour? It's going to be 2.5. So I'm going to say C is equal to 2.5 times the time. And my time will be in hours. And my C will be in dollars. So I don't really have a y-intercept because I don't have an initial cost. If I had an initial cost, that's when I would put it as C is equal to 2.5t plus that initial cost. But since I don't, I'm just going to put 0. So the next part of the question is asking, use your equation to find the cost of parking for 24 hours. So then my cost is going to be 2.5 times 24. Right. So I can just put that in my calculator to give me 60. So my cost for 24 hours is going to be $60. So part F of my question is use the equation to find the number of hours a car was parked in the lot if they paid $90. So my cost is going to be $90. And then I know it's 2.5 times t. I'm asked to find how many hours, meaning what's my t value. So I can isolate for my t by simply dividing both sides by 2.5. So 2.5 will give me 1t, and then 90 over 2.5 is 36. So it's going to cost $90 for 36 hours. The inequalities. So this is a grade 12 advanced functions question that was sent in. So it's dealing with polynomial inequalities. So the equation f of t models the bacterial count in thousands per sample of tap water. So f of t is tap water and then we have another function that's g of t, which models the bacterial count in thousands. So for a sample of pond water that is left to sit over several days, so in both models t has to be greater than 0. Will the bacterial count for the tap water sample ever exceed the bacterial count for the pond water? Right? So this is my tap water, this is my bacterial count for my pond. So this is pond. So they're asking, will tap water ever exceed bacterial count for pond water? So that means f of t, will that ever be greater than g of t? Right. So let's go ahead and substitute the equations that were given to us for f of t and g of t. So I have 5t over t squared plus 3t plus 2. Is that greater than 15t over t squared plus 9? Right. So I can bring all the terms over to mean 5t over t squared plus 3t plus 2 minus 15t over t squared plus 9. Is that greater than 0? Right. So then we have to try and factor out my denominators to see if I can get common denominators. So I have 5t over t plus 2, t plus 1. Minus, I'm going to keep the second term to be the same. So greater than 0. And then we're going to use common denominators to evaluate this. So I end up with 5t, t squared plus 9, minus 15t, t plus 2, t plus 1. All that's over my common denominator of t plus 2, t plus 1, and then t squared plus 9. Is that greater than 0? So the reason I'm doing all this is because I need to construct an interval table at the end. And I want it to be greater than 0 because that's something I can evaluate easily. Right. So all of this expands and simplifies to give me minus 10t cubed minus 45t squared plus 15t. That's still, my denominator does not change. T plus 1, t squared plus 9. So if you sent in any questions, we'll reply to you as soon as we can. So we're going to try and factor the top term now. So I'm going to take out a negative 5t to leave 2t squared plus 9t minus 3 over the same denominator. And I'm going to try and factor the top with my usual method, but I don't think I can, so I'm going to plug that into my quadratic equation. So just to recap, quadratic equation is minus b plus minus b squared plus 4ac over 2a. This is minus. And then I'm just plugging in this quadratic into my quadratic equation to see what are my t values. So I end up with t is equal to 0.312, or t is equal to negative 4.811. Right. So my x-intercepts for my quadratic over here is going to be 0.312 or negative 4.811. So then I'm going to set up an interval table. So let's expand this. So if I look at all the factors in this inequality, I have t, which is equal to 0, or t can equal, what I found earlier was 0.312. T is equal to negative 4.8. Both these are from the quadratic, which I solved using the quadratic equation. And then my denominator gives me t is equal to negative 2, t is equal to negative 1, and this can never equal to 0. So then I'm plugging it into my interval table. So I have t is less than negative 4.8. T is going to be between negative 4.8 and less than negative 2, and t will be negative 2, between negative 2 and negative 1, and then negative 1 to 0, and then 0 to 0.312. And then one final term is going to be t is greater than 0.31. Right? So I know my t can't be a negative because they initially told me t has to be greater than 0. So I'm going to discount everything that's before 0. So I don't care about any of these values. So I'm only looking at t is between 0 and 0.31, and then t is greater than 0.31. Right? So to do that, I'm just going to plug in some number between 0 and 0.31 into my initial function, and that should give me a positive number. And I'm going to do the same for when is t greater than 0.31. So I'm going to plug in a really big positive number, and that's again going to give me a negative number. Right? So my initial inequality is asking, when is this big polynomial, this rational function, when is that greater than 0? So I found that that function is only greater than 0 when t is greater than 0 and less than 0.31. So my answer is going to be between 0 and 0.31. So we're moving on to the next question that was sent in. So it's a grade 10 math factoring question. So we have to factor this. So I'm just going to rewrite this: x squared minus 8x plus 16 minus y squared. Right? So as soon as we look at this, we should identify one thing, is that my first three terms look like a proper trinomial, and there's a minus y squared, so I'll leave the minus y squared till the end. And I also recognize that the first three terms are a perfect trinomial. Right? If I square root 16, that gives me 4. If I multiply by 2, that gives me 8. And if that's the same as my b value, then I have a perfect trinomial. Right? If my leading coefficient is 1, I can always do this check. I can square root my c value, multiply that by 2. If that's equal to my b value, then that's a perfect trinomial. So I have x squared minus 8x plus 16. I found that it's a perfect trinomial, so I'm going to write that as a trinomial, a perfect trinomial. So that's x minus 4 squared minus y squared. Right. So I can check my answer by just expanding x minus 4. X minus 4, that should give me x squared, and then negative 4 times x. Negative 4 times x gives me negative 8x. Negative 4 times negative 4 is plus 16, and those are my first three terms. So then I'm not done yet, because this is a square, this is a square, and there's a minus between the two squares. So that should remind you that you should be trying to look for a difference of squares. So the difference of squares tells me I get two factors, and the first term for each factor is the square root of my first term. So in this case, the square root of x minus 4 squared is just x minus 4. And the sign between the first and second term in each factor is going to change, because when I have difference of squares, let's take a simpler example of x squared minus y squared. If I have x minus y, x plus y, when I do the FOIL method or when I expand, my x times positive y, x times negative y is going to cancel out to give me just x squared minus y squared. Right? So similarly, I'm just going to do the square root of my second term, which is just y. So I have x minus 4 plus y, x minus 4 minus y. So once again, we're just doing questions that students have been sending in. If you have any questions, please feel free to send them in. So this equation just simplifies to x plus 1, x plus y minus 4, and x minus y minus 4. Okay. So once again, just to recap, I recognize that the first three terms make the perfect square. I check that by square rooting my c value, which is 16, and multiplying that by 2 to see if that's going to give me my b value. And it did, so I know it's a perfect square, so I made x minus 4 squared minus y squared. And I noticed that it's a difference of squares, because I have a first term and a second term which are squares, and a minus sign between the two, and then I evaluated it like a difference of squares. So this question is saying the height of an arrow shot on Neptune can be modeled by this quadratic equation. So h is height, t is time in seconds. Use a quadratic formula to determine when the arrow will hit the surface. So height in meters is interesting because we can get some information from it. So height, if it's greater than 0, that's telling me it's above the ground. If it's less than 0, it's below ground, right? So that means height at exactly 0 is going to be when the arrow will hit the surface, right? So we're finding what are when my y is equal to 0. In other words, I'm finding my x-intercepts. So I'm using the quadratic equation to find my x-intercepts. So I have my height, which is 2.3 plus 50t minus 5.57t squared. So I can rearrange this to write in the general equation for my quadratic. So it's negative 5.57 t squared plus 50t plus 2.3. Right? So this is my a value, this is my b value, this is my c value. So I label those because my quadratic equation requires those values. So my quadratic equation is minus b plus minus b squared minus 4ac over 2a. That's going to give me my time. That's going to give me my x-intercepts. So I'm going to go ahead and plug in my value. So my b was 50, so minus 50 plus minus 50 squared minus 4a is negative, so negative 5.57. And my c is plus 2.3. And all this is divided by 2 times my a value, which is negative 5.57. So this evaluates to some decimal number, so I have a negative 0.0457, and then I have t is equal to 9.022. Right? Since this is a function that's telling me height in terms of time, my time can never be negative, so it has to always be greater than 0. So I don't account this negative value, and I'm only accounting for the positive value. Right. So my answer is only this number. So my time at 9.022 seconds, my arrow will hit the surface of Neptune. So this is a common question. So they're asking me to find the 2D area for this shape. So it's an irregular shape. It's not a typical square. It's not a typical rectangle. It's a combination of multiple shapes. So I have a square, it seems like, with equal sides of 10 centimeters. And then I have half a circle and another half a circle. Right. So these two half circles will add up to make a full circle. So I can simply say my total area is going to be my area of my square and my area of my circle. So the area of the square is going to be, each side is 10 centimeters, so I know it's going to be 10 my length times width. So I can say length is one side, width is the other side, they're the same. So I have, for my square, it's going to be length times width, which is just 10 times 10. They're using centimeters as units, so I have centimeters, so that gives me 100 centimeters squared. Right. My circle, the area for a circle is pi r squared, so my radius is going to be half of my length of my square, which is just 10 over 2, which is 5. So I have pi times 5 squared, which gives me 25 pi. Right. So my total area is going to be 100 centimeters squared, so this is again centimeters squared, plus 25 pi centimeters squared. So if I plug this into my calculator, it's going to be roughly 139.3 centimeters squared. Right. If I was asked to find the perimeter of the same shape, I can employ a similar method. So I know both of these make up one full circle. And I know the radius of the circle already, it's 5 centimeters. And from the square, I only have two sides. I have this and this side. And I know both the sides are the same length. So my perimeter is going to be the circumference for the circle, which is 2 pi r, plus the two sides of my square, which is just length times width. So length and width. So I have 2 times pi times 5, plus 10 and 10 gives me 20 centimeters. So in total, I have 51.4 centimeters as my perimeter. Right? So whenever you're evaluating the surface area, volume, area, perimeter for irregular shapes that combine multiple shapes, just evaluate them individually and then just add them up together at the end. Alright, so that about does it for me today. So thank you for tuning in and hope this has been helpful.